Okay, so today we're diving into something, well, pretty fundamental. What does it actually mean to believe something?
Right.
And, you, our learner, you sent us some really intricate stuff, excerpts from the Stanford Encyclopedia of Philosophy on uh, on these formal representations of belief.
Yeah.
It's like we're trying to get to the bedrock of how philosophers try to model this whole idea. So our mission, should you choose to accept it, is to kind of unpack all these sophisticated ideas and see if we can extract some core insights, almost like give you the cheat sheet to understanding this field.
Yeah.
We're basically asking, like, the questions a philosopher would grill you on.
Yeah, exactly.
Like, what is belief at its core? What even makes some beliefs rational and others not?
Right.
And, like, how should our beliefs change when we get new information? Like, all the time.
Yeah, all those dynamic elements of belief. It's a pretty huge question.
Yeah, so, I mean, it's not just like, scratching the surface.
Yeah.
These are, like, hardcore, formal methods, like with math, with logic.
Yeah.
These are the tools that philosophers use to build these really rigorous frameworks.
Yeah, I mean, it's an attempt to really get precise about what it means to believe something.
Exactly.
Like to have a very tight and kind of well-defined notion of what it means to hold something as true.
Yeah, and so why even go down this road of formalizing belief?
Yeah.
Like, what's the driving force?
I think the core motivation, and I think this is really at the heart of much of epistemology, is to understand the ideal of rational belief.
Okay.
So philosophers are using these mathematical models to try and pin down how a perfectly rational thinker should manage their beliefs.
Right.
This covers everything from, ensuring our beliefs fit together in a coherent way. So like making sure that there's no contradictions in what we believe.
Yeah, like logically consistent.
Exactly. To then like how those beliefs should guide our decisions, right? So like if I believe this and I have these goals, how should I then act?
And then to how we should properly incorporate new evidence.
Exactly,
To
yeah.
get new information. How do I rationally integrate that with my existing beliefs?
Yeah.
So it's kind of constructing this like perfect blueprint for reasoning about and updating what we believe.
Yeah.
And I think the initial insight here is that it's an attempt to go beyond just like intuition and gut feelings about what seems reasonable.
Okay, yeah.
And try to create precise standards for belief.
Okay, so you're talking about like rational belief, managing beliefs, beliefs fitting together. But when we talk about belief in these like formal systems, what exactly are we believing in?
Yeah.
Like what are the building blocks of belief?
That's a great first question.
Yeah.
I think it's one that philosophers have debated.
Okay.
Are we believing sentences?
Okay.
So like the actual words, or are we believing propositions?
Okay.
The kind of underlying meaning or content.
Okay. So like it's raining and it is not the case that it is not raining.
Right.
Those are two different sentences, but they seem to express the same underlying thought.
Same idea.
Same idea. And so the question is like, when I believe that it's raining, am I believing the sentence or am I believing that proposition?
Right.
Our source also mentions more nuanced ideas like centered propositions,
Okay.
which involve indexicals, like words like I, here, now.
Okay.
Right. So these are important for capturing beliefs that are like tied to our individual perspectives. So like I am hungry is a centered proposition. It's about me. It's about like right now. It's about where I am.
Okay. So like I am here now is a different kind of belief object than like 2 + 2 = 4.
Exactly.
Okay.
2 + 2 = 4. That seems like it's just true. Like absolutely.
Okay.
Whereas I am here now is really capturing like the who, where, when of a belief.
Yeah.
But for this deep dive, given our source material, we're mainly going to focus on propositions as the objects of belief.
Okay.
And propositions in this formal sense are often understood as sets of possible worlds.
Okay. So possible worlds.
Yeah.
That's a whole other can of worms, I feel like.
It is.
So in a philosophical context, like what are we talking about when we talk about possible worlds?
Yeah, so I think it's helpful to not think of them as like fully fleshed out alternative universes, right?
Yeah.
Not like some other dimension where everything's different.
Okay.
Instead, think of them as just ways things could be, focusing only on what's relevant to the belief in question.
Okay.
So for instance, let's say I believe that that the next president will be a woman.
Okay.
So the possible worlds that we're considering are those where a woman is elected and those where a man is elected.
Right.
We don't need to worry about whether there's a parallel universe where cats can talk.
Right. Okay.
Unless that somehow becomes relevant to the election outcome.
Yeah. Okay, I see.
So a proposition then is just the collection of all those possible worlds where that proposition is true.
Right.
So it's a very precise way of defining what is the content of a belief.
Okay, so like a proposition like carves out
Yeah,
a specific set of possibilities.
exact.
Okay. Now, how do these propositions like relate to each other?
Yeah,
Do they have like their own kind of logical structure?
they do. And because propositions are sets of possible worlds,
Uh-huh.
they kind of inherit the structure of set theory.
Okay.
So the negation of a proposition, right? Not A.
Yeah.
It's just all the possible worlds where A is false.
Okay.
That's the set's complement.
Okay.
Conjunction A and B, that's just the intersection. Like
Okay.
that's the worlds where both A is true and B is true.
Okay. Cool.
Disjunction A or B, that's the union.
Okay.
That's the world where at least one of them is true. The material conditional, if A then B, that's a little more complicated, but basically it's true in all worlds where either A is false or B is true.
Okay.
And so, this structure is really fundamental to understanding how beliefs can logically relate.
Yeah.
We can talk about whether one belief implies another, whether they're consistent or inconsistent, whether they're equivalent, and so on.
Right. And so this allows us to define like all sorts of logical relationships between beliefs, right?
Exactly.
Like entailment, equivalence, all that.
Exactly.
Yeah.
So entailment, that's the case where the set of worlds where one proposition is true
Uh-huh.
is entirely contained within the set of worlds where the other is true.
Okay.
Logical equivalence, they're true in exactly the same possible worlds.
Got it.
Tautology, true in all possible worlds. That's the universal set.
Right.
Contradiction, true in no possible worlds, the empty set.
Okay.
We can talk about consistency.
Yeah.
That means there's at least one world where all the propositions are true. Inconsistency, there isn't. Mutual exclusivity, they can all be true at the same time, and so on.
Wow. It's like a whole other way of looking at logic, right?
It is.
Like mapping it onto these sets.
Yeah.
The entry also mentions something called the deduction theorem.
Yes.
What's that about?
So the deduction theorem formalizes a very natural idea that we use in logic,
Oh, okay.
which is that, if you can logically derive a conclusion, let's call it B, by assuming a premise A,
Uh-huh.
then you can prove that the conditional statement, if A, then B, is true.
Yeah.
It's essentially saying, like, if assuming A gets you to B, then we've basically proven that A implies B.
Right. It's like turning these, temporary assumptions
Yeah.
into like permanent logical connection.
Exactly.
Okay, now, how do these propositions and possible worlds that we've been talking about,
Yeah.
how do they connect back to formal languages, the symbols that we're using?
Yeah, so every formal language, right, with its symbols and its rules for combining them, that language naturally defines a set of possible worlds, which we call models of that language.
Okay.
And a model is essentially, it assigns a truth value
Okay.
to every sentence in the language in a way that kind of respects the rules of the language.
Right.
So sentences in the language then express propositions.
Uh-huh.
They pick out the set of models in which they're true.
Yeah.
So the language gives us the tools to describe and work with these sets of possibilities.
Okay, so it's like language acts as a way to like describe and define these sets of possible worlds.
Exactly.
Okay. Now this brings us to the distinction between, sentences and propositions.
Yeah.
And this thing that comes up in the entry, this assumption of logical omniscience in these models.
Right. And this is a critical point where the idealizations of formal models, I think, become very clear. So while different sentences can obviously express the same underlying proposition, like it is raining, and it is not the case that it is not raining.
Yeah.
A real person might believe one of those without immediately realizing that they also believe the other one.
Right.
Right.
Yeah.
But many formal models operate under this assumption of logical omniscience, which means that, a rational agent in this model is assumed to instantly recognize all those logical equivalences and immediately believe all the logical consequences of their beliefs.
Like setting the bar pretty high.
It is a very high bar, to be logically omniscient.
Yeah.
Our source actually mentions philosophers like Hacking, Garber, Pettigrew,
All right.
who've explored ways to build models that relax this very strong assumption.
Okay.
Right. To better reflect the limitations of human reasoning.
Right, because, I mean, obviously none of us are truly logically omniscient, right?
I'm not.
Yeah.
But for many, I think foundational models, logical omniscience, is a simplifying assumption that allows us to, kind of treat sentences and the propositions they express as largely interchangeable
Correct.
for the sake of analysis.
Okay.
So it's crucial to remember this gap between like the ideal model and reality.
Right.
When we're thinking about how these theories apply to actual belief.
Yeah. Okay. And the entry also, I think, just very quickly notes that for these beliefs that involve indexicals, I here, now,
Yeah.
that these standard propositions might not be enough.
Right.
You might have to think about centered propositions,
Exactly.
which, include the agent's perspective. But I guess for the sake of this deep dive, we're going to stick with the standard proposition.
Yeah, we're going to keep it a little bit simpler for now.
Yeah. Okay, cool. So that was a lot of groundwork.
Yeah.
So let's move on to how these frameworks represent full belief, like, the kind of all or nothing belief that, we talk about in everyday life.
Yeah, so this tradition in epistemology views belief as kind of a binary state.
Okay.
You either fully believe a proposition, you disbelieve it, which is just to fully believe its negation, or you suspend judgment.
Right.
Right.
Okay.
So there's those three options.
Okay.
The case of believing both a proposition and its negation, that's usually considered, a sign of irrationality.
Right.
And not something that these models typically accommodate for rational agents.
Okay. So, for a rational believer in these models, it's a clean choice.
Yeah.
Either believe, disbelieve, or neither.
Right.
Okay. Now, how do these frameworks represent the entirety of someone's beliefs?
Yeah, so the idea is that at any given moment, an agent's belief state is just the set of all sentences or propositions that they fully believe at that moment.
Right.
And as we touched on earlier, for a belief state to be considered rational, it typically has to be deductively closed, meaning it includes all the logical consequences of the things it contains. And it has to be consistent, meaning that it doesn't contain any contradictions.
Okay.
So this idea of a, deductively closed and consistent set of beliefs, that's kind of, I think, a cornerstone of many formal theories of belief.
Consistent and closed under deduction, yeah.
Yeah.
That seems like a pretty basic requirement for a rational set of full beliefs.
Yeah, these are like the static requirements, right? Like at any moment your beliefs have to be like this. But the entry hints at these frameworks, they get more interesting when we look at how beliefs change over time.
Exactly. Because, it's one thing to have, a coherent set of beliefs, right now.
Yeah.
But, we constantly get new information.
Right.
So it's not just about, having this coherent set now, but having, a rational method for revising those beliefs when new evidence appears.
Exactly. So while these kind of static principles of rationality are important, consistency, closure, the real, I think, power of these frameworks comes when they try to model the dynamics of belief.
Right.
How these belief states should be updated when an agent encounters new information.
Yeah.
So I think there's general agreement on these static requirements.
Okay.
But different frameworks often propose different rules for how beliefs should rationally evolve over time.
Right, because there are, presumably there are many different ways to rationally change your beliefs, right?
That's right. Yeah.
Okay. Now, the entry also mentioned bridge principles, even in this section on full belief.
Yeah.
What are those all about?
So these principles are about trying to connect the idea of full all or nothing belief with this idea of degrees of confidence, so partial belief.
Okay.
And the thought is that sometimes by analyzing how an agent's degrees of belief might change, we can actually gain insight into how their full beliefs
Could be updated.
Okay.
So, for example, some theories suggest that that we fully believe something when our degree of belief in it, crosses a certain threshold.
Okay.
So these bridge principles are all about providing a more unified picture of how these two ways of thinking about belief might relate.
Right. So you're not just keeping them separate. You're trying to see how they might connect.
Exactly.
Okay. So now one of the frameworks for full belief that's discussed is this thing called non-monotonic logic.
Yeah.
So this sounds like a bit of a departure from standard logic that, I guess, most people encounter.
Yeah, I mean, in standard deductive logic, if a conclusion follows logically from a set of premises, adding more premises never makes that conclusion false.
Right.
That's called monotonicity.
Okay, yeah.
But a lot of our everyday reasoning, we draw conclusions based on, like, the best available evidence.
Right. And those conclusions might have to be retracted.
Yeah.
If we get new information.
Yeah.
So that's non-monotonic reasoning.
So it's like the conclusions we reach are like provisional.
Yes.
Right. Like based on what we know now.
Uh-huh.
And we might, we have to be ready to change our minds.
Yeah. And I think that definitely sounds closer to the way we actually reason in the real world.
Totally, yeah.
It's like, think of it this way. Our initial evidence, that's like the hard evidence.
Okay.
And then the defeasible conclusion is something we're justified in believing based on that evidence.
Okay.
Even if it's not strictly logically entailed.
Okay.
So, for instance, if I see a bird, I might defeasibly conclude it can fly.
Right.
But then if I learn it's a penguin,
right, yeah,
I've got to retract that conclusion.
Yeah.
And so this kind of reasoning is called ampliative. The conclusion, kind of goes beyond what's strictly contained in the premises.
Yeah.
And it's this hallmark of non-monotonicity.
Okay, so non-monotonic logic is trying to, like, formally capture this, more common sense reasoning.
Exactly.
Where we make these plausible inferences. That might be wrong.
Yeah.
Okay, and so the entry mentions System P as like, one of these kind of basic frameworks for these logics.
Yeah.
So what are its properties?
So System P lays out some basic properties that any reasonable system for defeasible reasoning should have.
Okay.
So one is called reflexivity, which just says that anything defeasibly follows from itself.
Okay.
Right? A implies A.
Yeah, okay.
Left logical equivalence just means that if two premises are logically equivalent, then they should lead to the same defeasible conclusions.
Okay.
Right? Weakening says that if something defeasibly implies a conclusion, then it also defeasibly implies anything that follows logically from that conclusion. So these principles, they suggest that, defeasible reasoning includes standard deductive reasoning as a special case.
Okay.
Right? Our everyday reasoning is often building upon, basic logical principles.
Totally. Okay, so what about the other key principles in System P?
Yeah.
Cut and cautious monotonicity.
Yes.
Those are some mouthful names.
They are. Cut basically says that if I can defeasibly infer a conclusion from some premises, and then I add that conclusion back to my premises, it doesn't allow me to derive any new conclusions that I couldn't derive before.
Okay.
Cautious monotonicity, on the other hand, says that if I can defeasibly infer two conclusions from a set of premises, then adding one of those conclusions to the premises won't make me lose the ability to infer the other.
Okay.
So think about it this way. If our initial evidence kind of points towards a certain explanation, learning a consequence of that explanation shouldn't make us doubt. Okay.
The initial conclusion.
Okay, yeah, that makes sense. Like you're building on it.
You're building on it, exactly.
Yeah.
And cautious monotonicity actually has some interesting connections to the idea of hypothetico-deductivism. Okay. Where we're testing theories by seeing if their predicted consequences hold true.
Okay.
So, if I have a hypothesis and I can derive a consequence and that consequence turns out to be true, that kind of gives me more evidence for the hypothesis. Okay. And that's kind of the spirit of cautious monotonicity.
So these principles, they aim to, capture, I guess, this form of defeasible reasoning, like both, flexible enough to handle new information, but also, stable and consistent.
Exactly.
Okay. Now, System P also includes and conditionalization. Yeah. So what do those tell us about this kind of defeasible reasoning?
So the OR rule, sometimes also called case reasoning,
says that if a conclusion defeasibly follows from two separate premises, then it should also follow from the OR combination of those premises. Okay. So this allows us to reason by considering different possibilities. Okay. Conditionalization states that if the combination of two premises defeasibly leads to a conclusion,
Okay.
then the first premise alone should lead to a conditional,
Okay.
where the second premise is the if part,
Yeah.
and the conclusion is the then part.
Okay.
So it's connecting, this kind of diffusible consequence with conditionals.
Okay, yeah.
Yeah.
The entry mentions that this conditionalization principle can be a little problematic, especially when we think about inductive reasoning.
Yeah.
Drawing these general conclusions from, specific observations.
Yeah. I mean, the worry is that conditionalization seems to imply that any inductive leap that we make must have been lurking as a conditional belief
Right.
from the very beginning. So, if after seeing many black ravens, I defeasibly conclude all ravens are black, right?
Yeah.
Conditionalization might suggest that I must have initially had this really complex, defeasible belief.
Okay.
Like, if I observe many ravens and they are all black, then all ravens are black.
Right.
And then it just feels a little circular.
Right. Yeah.
And it doesn't quite capture the sense that induction is about genuinely learning something new.
Right, yeah.
That goes beyond our initial premises.
Okay, so it's like it makes induction look a little bit more like deduction.
Exactly. Yeah.
Okay, yeah, from very complex initial beliefs.
Yeah.
Okay. Now, moving beyond System P.
Yeah.
The entry introduces System R by adding rational monotonicity.
Yeah.
So what's the idea there?
So rational monotonicity is a stronger version of cautious monotonicity.
Okay.
And it says that if I defeasibly believe something based on my current evidence, and a new piece of evidence is consistent with my current beliefs, then adding that new evidence shouldn't make me retract my original belief.
Okay.
The intuition here is that new compatible information should kind of reinforce, not undermine our existing defeasible conclusions.
Okay.
It seems kind of, at first glance, quite reasonable.
It does. But then, of course, the entry gives some very compelling counterexamples.
Yes.
That suggest that it might not always hold.
It might not.
So can you walk us through one of those examples?
Sure.
Yeah.
So consider the case of Sophia.
Okay.
And Sophia believes that Verdi is Italian.
Okay.
And Bizet and Satie are French. Now, this seems like a pretty reasonable set of beliefs, right?
Yeah.
Based on common knowledge.
Yeah.
Now, if she learns that Verdi and Bizet are compatriots, she might revise her beliefs to think, okay, maybe they're both Italian or they're both French.
Right.
But she'd probably still believe that Satie is French,
Yeah.
based on, the separate information.
Okay. Okay.
Yeah.
Yeah.
But then, if she learns that Bizet and Satie are also compatriots, rational monotonicity might suggest that she should still hold on to her belief that Satie is French.
Right.
And conclude that, well, they must all be French.
Yeah.
But intuitively, I think it seems perfectly rational for Sophia to now retract her belief about Satie being French.
Yeah.
And just conclude that, okay, all three composers are either Italian or they're all French.
Yeah. Yeah.
And so what this is highlighting is that the reasons behind our beliefs actually matter.
Yeah.
Right? There's this kind of structure to our justifications.
Right, yeah.
And a purely logical approach might kind of miss those crucial inferential links.
Totally. And that comes up, again, with the example of Alice, Bob, and the Ford.
Exactly, yeah. So, suppose Sophia has some evidence that Alice owns a Ford.
Okay.
And weaker evidence that Bob does.
Okay.
She might defeasibly conclude that someone in the office owns a Ford.
Right. Right. Okay, yeah.
But then Alice announces that, oh, actually, she was just renting the car.
Right.
She doesn't actually own one.
Okay.
And so that defeats the primary reason for Sophia's belief.
Yeah.
And it seems rational for Sophia to now retract her conclusion that someone owns a Ford.
Yeah.
But rational monotonicity might insist that since that information about Alice renting the car is consistent with her initial belief, right?
Yeah.
It doesn't directly contradict that.
Yeah.
She should still hold that belief
Yeah.
and now conclude that, oh, it must be Bob.